Hello, this is Brian. I'm going to show you a quick science experiment here to dispel the myth that water conducts electricity. This is something frequently in automotive forums when I mention when people are concerned that connectors or wires, adjoining wires or sensors, they get wet, that they get shorted out, and I say, well, water doesn't conduct electricity, at least at low voltages. So what I have here is a cheap, almost disposable flashlight, and inside of the flashlight are 3 cells. Each cell is a volt and a half for a total of 4.5 volts. And this is pretty relevant because the voltage in automotive applications are many of the sensors run on a 5 volts. TPS, for example, I believe is 5 volts. There's also an 8 volt sensor. So we have this flashlight and it's working just fine. And of course, not only is this a battery operated flashlight, but it has LEDs in it, semiconductors. Now certainly semiconductors we don't want to get wet. That's the same stuff they have inside of computers. So, but we'll drop it inside the water and, well, it kind of floats. It must have got air trapped in it. So we're going to make sure we get all that air out. So you see the bubbles come up there, so we got some air out. And put it back together here. Well, somehow the thing is still working. Okay, well, maybe it's got some air trapped in the other end here. Well, nope, we got all the air out of here. Okay, well, let's put it back together. Still working. Okay, well, let's I bet it's short the switch out though. Let's turn the switch on and off. Geez, I can turn the switch on and off and it doesn't get shorted out. Something just doesn't make sense here. Okay, so we'll take it out and shut it off here, and we'll see if maybe there wasn't any water inside of it. But of course, when I open it up, a bunch of water comes out. Well, what are these things here? Well, look at, there's these black O-rings. Oh, well, why do they have O-rings on this thing if water is not going to hurt it? Well, the reason why O-rings are there is because water isn't a problem, but trapped water is. If water's trapped in there, it will accelerate corrosion. The same thing with people might ask, oh, why don't you use a laptop or a cell phone for this experiment? Well, laptops have what's known as a mylar membrane keyboard, and the mylar membrane keyboard, if water gets trapped in there, it doesn't have a way of drying out, and so eventually it'll get mineral spots, and connectors will get corroded inside the laptop. Same with cell phones. Cell phones don't have a lot of airflow inside of them, so the components can easily, small areas can get water trapped, and you have the exact same situation. Well, what about high voltage? Well, why don't I use a lamp, my desk lamp, for this? Well, high voltage, of course, if the voltage is high enough, it can ionize air. Electricity or lightning is ionization of air. Water ionizes at a much lower voltage, and 120 volts, if I put a desk lamp in here, it would ionize the water and it would short out. Ionization is the process of getting electrons to move. Copper electrons move really easy, and water they don't. So water is a very effective insulator. Distilled water is a perfect insulator, but minerals will make it more conductive. Salt water, if you put enough saline in water, that is perfectly conductive, and it will conduct rather well. So that's my experiment. Thanks.